Hey everyone, let's solve some LeetCode problem today. And the problem is reverse words in a string. Given an input string S, reverse the order of words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space, so there can be multiple spaces splitting each word. Return a string of words in reverse order, concatenated by a single space, so no trailing spaces allowed. Note that S may contain leading or trailing spaces or multiple spaces between two words. The returned string should only have a single space separating the words. Do not include any extra spaces. So let's take a look at some examples. So the sky is blue and each word is taken and the order of words are reversed. So the sky is blue. So the word content is not touched, it's not reversed, it's the original, but the order of each word is changed. And in the case of where we have trailing space, we also extract words hello and world and reverse, put them in reverse order. World, hello. A good example. So this has leading space in between, and this also should be removed. So do I have any like if I were in real interview, what kind of questions I would ask? So my question is, do we always have English characters, English alphabet characters on our string as a word? For example, what should we do if we have digits, if we have some question mark like uh, characters? How should we handle them? Should we treat them as a word or not? Should we ignore them? Or one more question that's coming to my mind is, what if we have dot in the end? So yeah, S contains English letters, uppercase and lowercase digits and spaces. So in case of uppercase, should we convert it to lowercase or just leave it as is? I think as there is no explicit mention, then that means we can just don't touch it. And there is at least one word in S, so it's not never empty. So one possible solution that's coming to my mind is iterating through this string one by one character at a time, and uh, constructing a list of words, list of strings. The sky is blue. So, and then iterate this list in reverse order and then generate the new blue is sky, the new string here. So it's easy, right? We are not going to use split function. We are just going to implement this extraction logic by ourselves and just iterate in reverse order and then construct our new string. So time complexity here is time is O of n because we are iterating through all of these words. And space complexity is of n as well, so we are creating new uh, array to store words. And yeah, this is time and space complexity for current solution. So let's jump right into code. It's clear enough. So let's initialize our list here for character. So do we actually need our index? So for now, let's not include it. So if character is not equal to empty space, then word is equal to empty string, word was equal to character. So else so it is if the character is equal to empty space and word word is not empty, then we can just append it to words. And then make it empty string again. So this should effectively extract list of words for us. For example, let's take an example here. Okay, and we have list of words in our hands, and what we are going to do with this word. So we have result, and for I in range when words -1, let's start from the end and then continue to the very first element, excluding it. We add it manually, and then step is -1. So result, we will append word i's element followed by empty space. So until this point, we'll have blue is guy in empty space and z is not included yet, so we add it after, or we can do it inside the for loop itself, so it would be more like beautiful one. If I is not 0, if I, then we also add empty space to result, so no need to do any manipulation after for, and then return this result here. So let's run this exam. I think let's check for syntax errors. So correct, seems like correct. Yes. And okay, refreshing, initializing result. and building that result. Seems like okay, and let's test this solution. So we have words in here and words for character. Let's use this for character. So our character is not this one, not this one, because so we append T to our word, H to our word, E to our word, and then we have space, and the word has the length of word is not equal to 0 as well, and we append Z to our words, and then word we reset, and same continues till the end. And one catch here, so it's not equal, but what if we have length word? What happens if we are on the last index and we have a letter? In this case, it will be skipped. So we check after for loop. We check if word is not equal to 0, then we bend it towards again. And yes, blue will be added as well. So we catch our logical error, and we are iterating through our array from last element to the very first one, and except for very first index, which is 0, we are appending empty space here. So I'm ready to submit. Can only concatenate str, not list to str. So words. We have a typo in here. This time it works. So it was just a typo. We were appending word. So this Python is not type safe. Doesn't prevent us from this kind of issues at compile time. So we have a follow-up question. If the string data type is mutable in your language, can you solve it in place with O1 extra space? Could we do it? Like, let's imagine we have this string in C programming language, and this is basically character array, right? We can definitely change it, it's mutable. And then what could we do? We could just reverse s, and then reverse each word separately in S. So let's take this short example. So this function does YKS empty space and then EHT. So we have this string. This is reversed one of original, and then we go this string, like we iterate through this string and just reverse this word and this word. Then what would be the result? And one problem that we would face would be trailing um, trailing spaces, right? How could we solve it? We could just keep record of index so that we after each word then we could just write the content of word beginning from this index and increment this index only after we write the correct word. So we can definitely code this. Let's give it a try. So let's start writing the code. So let's imagine we're given a list, str list, and we need to update it in place. So we have, let's reverse that. So list, so we have left and right pointers, 0 and len of L minus 1. So while left is small than right, we just swap them. So else left, else right will be swapped. Right, L left, and we increment the left pointer and decrement the right pointer. So no need to return the list, so it's reversed. Self dot reverse. It's reversed in place. Now we have, so let's write the input here. Blue is given. After reverse, we would have si e u l b here, and then we need to have self reverse words in S. Sorry, we are using L here. Again, we are given L. This time we need to reverse words. How do we do it? So we'll have left pointer, right pointer, and next word pointer. Next pointer, or all of them begin from 0, and while right is less than length of L, we do this, and then we have left pointer, right pointer. We update right pointer if else right element is not empty space, then it means we are inside word. So we update right, else the word finished. That means we are on here, so we need to update our L. So L left until right will be equal to reverse it L left right. So actually no need to have right, and then so we effectively reverse this in here, and left is still in here, right is in here. But there is a possibility that we might have multiple spaces in between. So how can we handle this scenario? So we need to have a condition that indicates we are in word, which will be false initially. If else left is not equal to empty space, then in word will be true. And L, so right will be equal to left. Else, if it is empty space, then we increment left. So in this case, we are just handling this scenario where we have spaces in the beginning. So we are not in the word. We keep incrementing left until we reach S in here. um, and then like we can continue here because we don't want these conditions will be reached if we are not in word. So after that, if right is on the space, the right index of the list is space, then we are out of word again. In word will be false. So do we actually using are we actually using this in word flag? Maybe we don't need this flag. We can just set left is equal to right here, and no need for this. And then this logic reverses each word in here. But the same will happen with the last index. Continue. If right is not equal to len L, only then we continue. If we are already on the last index, then we don't continue, we just do this. And then third step is self dot strip L. Self L, this is list, and it returns nothing. It just operates on this list directly. We have right left pointer and right pointer. Both of them will be equal to 0 at first. Then while right is less than length of L, so in each iteration right will be incremented, but before that, if right is not equal to empty space, then we need to do something, and that something is we need to update left pointer of L to be L else right, and L will be incremented only after overriding that position left pointer by 1. But we might have a case where we want to add space only if, let's imagine this input, let's imagine we have this, and here we definitely need a switch here in word false, in word true, and if right is equal to space and we are in word yet, then we update else left to be empty space, increment left by 1, and in word will be false again, and right will be incremented. And basically this is the solution that we have. For example, can we move to insert mode, or maybe just use another. Blue is, would look like this. After right pointer finished iterating. And again, we need to cover, we need to handle last index scenario. And when it will happen, so it's not empty space, then it should probably enter this statement or not. No, actually it doesn't need to. We don't need to append empty space here. And what else is being left? So on each iteration, we just update right pointer to be this. And in the end, return empty space and empty string join L should give us the answer if we don't have any issues. It's our code. So most probably we forgot to update some pointers here. So in reverse, we are updating left and right, so they will collapse. And in here, right is where are we updating our right pointer? So we are updating our right pointer if we have a word, we are in the word. Hmm. In this specific scenario, we will have right less than L. We will immediately find the word here. So we are in the word, we don't continue. Right is not empty space, it's T. We increment right. It's not in the end. Continue. Left is not empty space. And right is not a space, it's H right now. We increment by 1. Again, right is E this time. We increment right by 1. And the next time left is still not empty space, but right is empty space right now. And we just reverse this word, and after reversing we will set the position of left to be here and find the next word. So I think problem is not here in here. Let's check our strip function. Maybe we are missing something in here. Left and right begins from 0. So if right is a word, then we increment left by 1. Okay, we updated. Basically, we are updating the right pointer always on each iteration. So it can never be infinite loop, right? We are not breaking, we are not continuing, we always increment right pointer. So why in this case we are in the infinite loop? Most probably as we have a bit more complex logic in reverse words. Let's print L in here and test. So reverse words. Do we have a std out? No, we don't have a std out. Let's simplify the test case. Z. Can we run this test case? So let's update the first test case and run. So we are in infinite loop. But we don't know where it is happening. Or okay, let's open our terminal. Vim words.py UI and paste, and then solution dot reverse words and give z single word. It doesn't do anything. It shouldn't do anything. And on each iteration we print L. So reverse L. So this gives us very good postmortem if we can finish it. Print reverse words L. Strip. Python 3 reverse words. Reverse is working, and as we guessed, this reverse words is not working. Print. So why it's not working even in the simple case? So we are not right. So right will always be like refreshed in here. So we actually we need this switch false. If not in Word, our assumption was correct. If we are not in Word, then we need to just update set right to left. So when do we make our word true? So if right is not in empty space, then that means we are in word, inside word. We make it true. And when this code block is reached, that means we are not in word anymore. So we can make it false. And this time, we're still in the loop. Not in word, for example, Z. It's true, and left is not equal to right. Okay, this is first iteration. 0 will be equal to 0, and in word will be true. We increment right pointer, and in the second iteration, print left and right. Left. So this else condition, we need to update it as well. If not in word, and this code block will be executed only if we are not in word. Otherwise, we don't execute it. This time, reverse words works. Let's switch the input from the string from input, delete and input. Z man. Oh, strip is not functioning properly again. But reverse words is working. Print, print. You don't need this one. And print. So strip. This is not working correctly. Let's find out why. We are using inward in here, inward switch. Okay, we have man and Z words, and On first iteration, right is not equal to empty space. In word, so we set it true. Okay, fine. Right and left will be incremented. Oh, this one. It's waiting our input, the man. Man Z and Z man. Okay, strip is not working. We were supposed to have different thing. In reverse words, least index out of range. Print left and right. So yeah, let's check. And left is also less than length of L. Only then we do this. So reverse words working correctly. We are incrementing right on each iteration. So let's take this example. This is a good example. Paste it in here. So we are not in Word initially. So we have right and left initialized in here. So right is not equal to space. It's equal to, so we are not in Word. Then right will be incremented by 1. We are on the second space now. Again, right is on space, we are not in word, right will be M, on M now, but left didn't change, left one. And then right is not equal to space, that's true. We are in word, we set it true. Then we set left to right and increment left. So now left is updated and left is here right now. And right is in here. And right is not empty space again. We are in word. We left is equal to right again. So we updated. And we increment both left and right. So we are still in the word. And left is equal to right again, and left is in here now, right is in here, so in the next iteration it is equal to empty space and we are in word, so left will be updated as empty space, so left is empty space now, and right is still in here. We increment left, so left is in here, right is in here. Okay, we are not in word anymore. We are not on right is empty space, but we are not in word incrementing right to be here. And in the next iteration, we are still on the empty space, but not in word incrementing right. Here, in word. And we are not in word and it's empty space, so incrementing right again. And this time it's not equal to empty space, we are in word. So this now should be, this is our left and this should be T. And right left pointer will be incremented by 1. And right pointer as well. And again, right is in here, left is in here, and again, and left is in here, right is in here, and again, and then right is out of bounds of array, and that's it. Basically we can return the index, because we are generating new array, so it should have and turn left pointer. Okay, let's see how our L is changing on real time. Z man, it's not changing. It's not changing. It's not changing. It's not changing. But why? It's not changing a single character. We will have definitely a good postmortem after this session if we can finish it. Left, right. Left is always incrementing, but it's not supposed to do it. Even in the first iteration, it's incrementing, right? But why it's not incrementing? It's being incremented. Where exactly it's being incremented? I'm not sure why. So inward it's false, false. If right is not empty space, that means it's a character, it's a letter. And in this case, we check whether we are in word. We are not. Maybe we check for true. In word is true. If in word is true. Where left is being incremented? I cannot see it. Left, right, L. We are incrementing left incorrectly. Somewhere, but not in here, because its character we should definitely update it. Print if condition, print elif condition. If condition is always true. Even in our very first iteration. So we have a problem in if statement. Ah, right. Come on. Come on. This took very long. Come on. What's going on, brother? Yeah, definitely. Uh, uh, that's very interesting one, right? The man is debugging he is blind. So we can do one more thing here. So just yep, oops. Reverse words. Print result. We can print result, but the reverse words. Okay, what we can do is here strip returns index, new end is equal to this, new end, and let's give it a try. Blind, is he debugging, is man the. Cool, it's working. We have done it. The only problem was just forgetting to use right in here in correct form. Instead of index, we have used literal value. And our compiler didn't tell us, so we couldn't find it. So can you now understand, can you now feel the power of typing system? Definitely. Okay, cool. Then it was very interesting session. So we can write some postmortems here. Um, postmortem. So postmortem number 1. So we have submissions, we have runtime error in here, just because we have used reverse words, and the code was words append words. Postmortem number 1. Check your code for typo. And postmortem number 2. What can we say? So reverse was correct, was cool, working every time. And then here we Okay, so we had a case where we were out of bounds of this uh, word, like this list, this left pointer. So postmortem number 2 would be, so this is number 1. um, Using pointers in while include all of them in your check. So postmortem number 3, we have we didn't use our switch in here correctly because we were afraid of nested loops. So postmortem number 3, nested loops are okay. You will simplify them later. Okay, yeah. What else did we do wrong? This is kind of black box thinking, right? We catch them, we analyze them, just to make sure we don't um, like repeat them next time. So very first problem that we faced was while loop stuck on this one because we haven't used this global um, switch here. And the final one, the most interesting one, the most time consuming one was a typo. Typo. So how can we summarize this? How can we just get rid of this habit of forgetting things in here? It was obvious, but how? I couldn't see it. um, L dot right, else right. So what can we write for our postmortem? Okay, if everything seems fine, but not working, you definitely have a typo. Open your eyes. Bigger. This seems good, right? So let me unlock it. And yeah, this is perfect thumbnail for our YouTube. This one. So thank you everyone. Thanks for watching. It was cool session with you. Bye bye.